Jai Jinder, Namaste, welcome to my channel. Today we are going to solve the 26th question of the problem solving series, which is based on arrays. So the question is three-sum problem. The difficulty level for this question is medium, and this question has been asked in Google, Amazon and Apple. So three-sum problem, it is popularly known as three-sum problem. This is asked in a lot of companies as well. So in this question, we need to find triplets whose sum is equal to 0. So earlier we have solved two-sum problem, we have solved four-sum problem, so now we have three-sum problem. So can we use the techniques and different approaches that we used on those problems in this problem? But the difference is that we are not given the particular number here in this problem, that the sum should be the sum should be that value, but here it is fixed as 0. So there is no problem. If the problem is changed, you can even solve it. So what can we do? Also, there could be multiple triplets. We need to return the vector of vector in C++ or list of list in Python. List in Python. So what do we do? How do we solve this? So for this example, the elements are 0, -1, 2, -3 and 1. So if we take the sum of 0, -1 and 1, the sum will be equal to 0, right? So we have got one triplet. So 0, -1 and 1. Are there any other triplets? Yes. If we take the sum of 2, -3 and 1, its sum will also be 0. So we have these two triplets and we can return them. Okay. Here 0, 1, 1, there are three elements only, so the sum will be 2 and we won't have any such vector of vector, will be returning the empty list. So how do we solve this? Here in this problem I think the elements are unique, but if the elements are not unique, we can make them unique. We can take a set data structure and then we can make them unique. Otherwise the triplet should be copied and we want to have the unique triplet, so we will filter them out if it is not unique. So let's consider it is unique, because in this Geeks problem it was unique numbers. So how do we solve this? The first approach, the brute force approach, it's very simple. We can fix the first two part as I and j in the loop, two loops, and in the third loop we'll search for the elements and we'll see whether sum is getting equal to 0 or not of the sum of array I, j and k, the three variables. The sum, if the sum is equal to 0, then we will store those three numbers in the vector of vector, right? So the first approach, brute force approach, it would take the time complexity of order of n cube. Obviously we need to optimize it. How did we optimize in two-sum and four-sum problem? We use the concept of hashing. We stored the values and then we have to find, so in this case, in two-sum problem we stored the value and then we tried to find the number which was given minus one of the number and see whether the second number exists in the array or not. If that number existed in the array, we found the two numbers, right? So you can check my two-sum problem and four-sum problem also in the playlist series of problem solving series, and you will get the idea. Okay, so how will we use hashing over here? Same technique. So here we will store the values of the elements in the array in them, our hash set, the lookup kind of thing, the hashing thing, and we will do the sum of first two. We will have two loops and we will do the sum of array ai and array j, and we will see in the, when we go to the next elements, we will see whether the next element, when we will see whether the sum, whether the element in the map contains minus array I plus j. That means we have this I equal to 0 to n, j equal to I plus 1 to n, right? So if the sum, say sum will be ai plus aj, okay, and in our map, say in m, if m dot find minus sum is equal to m dot not equal to m dot n, that means if we have a number minus sum in our map, What does this mean? That AI plus AJ is sum and minus sum is also present in the map. That means sum minus sum will be 0. So what are our three elements? AI, AJ and the minus sum. So we have got the three elements and then we can store these three elements in a vector and then that vector can be stored in the vector of vector. In this way we can find all the triplets. We will obviously remove the duplicates if the duplicates are given. So in this way, with hashing, we can solve it in order of n square. I will not coding this. We have done this in 2 sum and 4 sum problem, but can we optimize it in 3 sum? Can we solve it in a better way? Yes, we can. We'll use the concept of 2 pointers. Okay. So 2 pointer and we will be using, for 2 pointer we have to sort them. Okay. So with 2 pointer and sorting logic, we can optimize this problem. If we are using sorting, then obviously the time complexity becomes order of n log n. Now how do we use 2 pointer technique to find the triplets? Okay, suppose these are the numbers, right? 0, minus 1. So if we take this example, so if we sort them, so our numbers would be minus 3, minus 1, 0, and then 1 and then 2, right? This should be our numbers, right? I should write it over, I should write it over here. Okay, so we have the numbers after sorting, sort them, and then we have minus 3, minus 1, 0, 1, 2. We have this sorted array. Now I'll take 3 pointers. Okay, we will start, we'll keep on traversing with it. It would be a fixed pointer, and then we will have 2 moving pointers as j and k. Okay, so the j value would be I plus 1 and the k would be n minus 1. We'll be taking it from the back. Okay, now observe one thing, that when I is fixed, if I do a sum of ai plus aj plus ak, right? So I is fixed, we can't change it, we are traversing it in the loop. But this aj, if this sum is becoming greater than 0, what does this mean? How can we need to reduce it to 0, right? So if this becomes greater than 0, that means if we move the k pointer or reduce the value of k, then only we can reduce this value, and then only there is a chance that it can become 0. So if this becomes 0, if this is greater, then we will reduce k minus minus. Else if it is smaller, then what we will do, we'll increase j, right? Then only it can become 0. So we will have a condition that j should always be less than k, and we'll be using this 2 pointer technique. And if the sum is equal to 0, we'll have the pair. Let's try to use this technique for this example. So I is fixed as minus 3. We have minus 1 and 2. So minus 3 minus 1 is minus 4. Minus 4 plus 2 is minus 2. So that is less than 0. So we need to increase j. So j moves over here. Okay, now minus 3 plus 0 is minus 3 and 2 is minus 1. So we don't get 0 again. Again it's less. So we will move again j. Now j is 1 and k is 2. So minus 3 plus 1 is minus 2 plus 2 is 0. So we have these 3 elements. These were the 3 elements, 2, minus 3 and 1. Okay, so this is, we can sort them, or it can be, we can take it anyway. So we have got minus 3, 1 and 2. Minus 3, 1 and 2, one of the pair. Now we move I. So once this is done, we move I and I becomes minus 1. Okay, j's value is j's value we can take, since we are moving it over here, we are taking it from here, so we can, our j and k can be the same value. We don't need to go back because it's already there. So we can, because anyway we are going to increase the values, right? So if we are starting from here also, then there is a possibility to get, this will solve our problem. So if I comes over here, then minus 1 plus 1, that is minus plus 1 is 0, and 0 plus 2 is 2. So if we change the value here while j is greater than k, then this will not find our problem, right? So anyway, when we are traversing, j is actually always greater than I plus 1. So j will actually move over here. Okay, 0 and 2. So let me code it and then you will understand. So let's find the solution first. So I is minus 1, then j is 0 and k is 2. So minus 1, 0 and 2, the sum is greater. So k will become here. K comes over here, minus 1, 0 and 1. The sum is 0. So in this way we get the second solution as well. So in this way we can solve this problem. So let's code it. Let's do the pseudocode. So what we have done, we are shorting it. Short AR plus n. Okay. Once the shorting is done, we have three variables in I equal to 0, j equal to 0, k equal to 0. Okay. So now for I equal to 0, 2 and minus 1. Okay. So here what we do, j is actually we can assign j is equal to I plus 1 over here, and k is equal to n minus 1 every time. Okay, and then what we do, we see the sum is equal to aj plus ak. Okay, and if ai, okay, this can be a temp value. Okay, temp equal to 0, temp is this. Okay, so if ai plus temp is greater than 0, that means we need to reduce the value, so k will become lesser. Else if ai plus temp is less than 0, that we need to increase j, or else if it is equal to 0, we have the elements. So if since it is a void, we can print it. If it is a vector, we need to return, then we can take a vector and then we can store it. So here see out ai, aj and ak, right? And endl. Okay, this is done. Else this is done. This is the loop, single loop, and yeah. So in this way we can solve the problem. If there is a duplication, we can avoid duplication. We can just avoid it when we are traversing. If it is ai equal to ai plus 1, then we will continue it. So in that way, in this way, with two pointers, we can solve this problem in order of n log n. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough section of the three-sum problem in LeetCode. So as you can see, we need to find three numbers that in the array whose sum is 0. So all those three unique triplets we need to find. So yeah, we have discussed these examples. So let's directly jump into the approach of two-pointer technique and shorting, by which we can solve it in order of n log n, the most optimized solution. So here in this example, you can see the number has been repeated, minus 1 and minus 1. So the numbers are not unique. So we need to remove the duplicate. So in this way we are checking num I, if num I is equal to num I minus 1 when we are traversing the array, then we will not go to this, we'll continue, and this way we will be avoiding the duplicates. And we have these two pointers, j equal to I plus 1, k equal to n minus 1, and we'll be using this technique which we discussed. If it is greater, the sum is less than 0, then we'll move ahead, we'll increase the j pointer, and if it is greater than 0, then we'll decrease the k pointer, and if otherwise if it is equal, we will store the vector in the vector of vector and increase the j and k pointer, and we'll check here if after increasing, if the numbers are same, then we need to avoid it, right? Because we can't store the duplicate triplets. So we'll increase the j and decrease the k if the next elements are same. Okay, so in this way we'll solve this. We'll directly submit this. And yeah, it has been accepted. So let me know in the comment section how was the explanation, and see you all soon in the next video where I'll be explaining the 27th question of the problem solving series. Jai Jinendra.